Welcome to Eight Minds, Multiple Intelligences, a practical framework for recognizing and cultivating diverse human potential. In this overview, we'll map out 8 distinct ways people think and learn, illustrated by the circular icon set on screen, and explain how educators and learners can honor different strengths while building balanced cognitive growth. This slide outlines Gardner's 8 filters, a set of multidisciplinary criteria used to validate each proposed intelligence. The graphic shows how evidence ranges from isolated brain damage and exceptional individuals to identifiable core operations, developmental history, evolutionary plausibility, experimental support, psychometric findings, and cultural encoding, stressing the need for robust, converging support before labeling a capacity as an intelligence. Linguistic intelligence centers on mastery of language, structure, expression, and persuasion, and includes skills like syntax, phonology, semantics, and pragmatics. Learners strong in this area thrive on storytelling and debate, enjoy journaling and wordplay, pick up foreign languages easily, and excel at crafting persuasive narratives across oral, written, and digital formats, making language a powerful tool for learning and communication. Logical mathematical intelligence emphasizes reasoning, pattern recognition, and abstract relations, moving from inquiry and hypothesis to coding, algorithmic thinking, and statistical inquiry. The slide's flow diagram highlights how systematic experimentation and quantification support controlled variable thinking and rigorous data analysis, equipping learners to model problems, prove assertions, and work fluently with numerical and logical structures. Spatial intelligence is about thinking in images and visualizing the world, which shows up in map reading, sketching diagrams, and mentally rotating objects. The icons on the slide point to tools like graphic organizers, mind maps, and art integration, while immersive virtual environments can help translate abstract ideas into clear, visual formats that make spatial reasoning more accessible. Bodily kinesthetic intelligence frames learning through movement and tactile engagement, progressing from motor skill control to gestures, maker activities, role play, and physical performance. The diagram highlights how hands-on practice builds procedural memory and deep, embodied understanding, suggesting that physical tasks and tactile feedback are central pathways to mastering many kinds of skills and concepts. Musical intelligence involves discerning pitch, rhythm, timbre, and tone, and using those capacities to compose, perform, and respond to patterns. The flowing musical motif on the slide underscores how songs, rhythmic mnemonics, and background scores can encode content, regulate mood, and enhance recall, turning melodic structures into effective learning supports across subjects and ages. Interpersonal intelligence focuses on understanding others through empathy, social perception, and collaboration, illustrated here by a circular model of related skills. People strong in this domain read moods and motives, lead discussions, thrive in cooperative projects, and support peer teaching, making social interaction both a method and goal of learning and of building effective teams and communities. Intrapersonal intelligence is about self-knowledge and metacognitive awareness, starting with accessing personal feelings, goals, and identity, and moving toward reflective practices. The slide links metacognition to concrete habits, keeping journals, setting learning targets, self-assessing, and regulating study habits, so learners can align academic tasks with personal values and foster sustained growth and resilience. Naturalist intelligence highlights the ability to discriminate natural phenomena and steward environments by classifying species, exploring ecosystems, cultivating gardens, and recognizing recurring patterns in nature. The visual layout connects observation, investigation, and environmental responsibility, arguing that integrating naturalist principles promotes ecological awareness while enriching interdisciplinary understanding across science and the humanities. This wheel presents concept-anchored lessons that approach content through complementary task types: narrative, numerical, visual, tactile, musical, collaborative, reflective, and ecological, each serving as an entry point for different intelligences. The idea is to teach from strong modalities while intentionally stretching weaker ones, creating balanced activities that honor learners' preferences and build broader cognitive flexibility. The final slide acknowledges critiques and points to future directions, noting limited evidence for strict, intelligence-matched instruction and the risk of neuromyths that fix learner profiles. At the same time, it sketches applied solutions: AI tutors for personalized learning, competency portfolios, and inclusive pedagogies that aim to support individualized growth without stereotyping, moving toward evidence-informed, equitable practice.